Okay, folks, section 10.7, graphing linear inequalities. Now, we've been solving, we have solved absolute value inequalities. Now we're going to graph linear inequalities. And you know what? It's really pretty easy. And it's also using stuff that you guys know and have been practicing for a long time, so it shouldn't be a problem for you at all. The first thing that you do, well, let's look at example 1. It says graph 3x minus 2y is greater than or equal to negative 4. First thing that you want to do is treat this thing just like it's an equation. Now it's not, okay? It's an inequality, but treat it like it's an equation, okay? And what we're going to do is we want to get it in the form of y is equal to mx plus b, okay? Whenever we want to graph, we want it in that form, okay? So, first thing I'm going to do is I'm going to subtract 3x from both sides. So now I've got negative 2y is greater than or equal to negative 3x minus 4. Okay? Now I'm dividing by negative 2, but remember this is an inequality. Okay? So when I divide by a negative, that means I need to flip the inequality. So now I've got y is less than or equal to positive 3 over 2x plus 2. Okay? It's exactly what we wanted. Get it in y equals mx plus b form. So look, here are the things we need. Here's the m, the slope, here's the b. Okay? Now the first thing that I do is I put a dot on the y-intercept at positive 2. Right there. Perfect. Okay? Now the next thing I do is I use the slope to find another point, up 3 over 2. You know, I like to just put all on here that I can, really. Down 3, back 2. Down 3, back 2. Down 3 is negative, and back 2 is negative, and negative over negative is positive. So you see I'm still getting the same slope. Back 3 over 2. Okay? Now this will help me draw my line. Alright? Let's see, I'll just put it right there and do my very best. Alright? And let's see. I'm going to go ahead and make it red, or try to cover it with red so it looks good. Okay? There we go. All right, there's my line. All right? Now, the only thing different between graphing the line and graphing an inequality, or that is graphing a linear equation as opposed to graphing a linear inequality, okay, is just that now we have to shade, because the solutions are not just the points that show up on the line. Remember, a graph is a picture of all of the solutions to an equation or an inequality. But with an inequality, the solutions are not just on the line. It's a whole sector, okay? Now, here's what I want you to notice. When we graph that line, it crosses the y-axis at the y-intercept, positive 2, okay? It crosses right there. And it cuts the y-axis into two parts. It cuts it into this part, the part that's less than the line, and it cuts it into this part, the part that's greater than the line. Okay? All of the numbers in the blue, on the blue part of the y-axis, all of these are less than the line. All the numbers that are on the green part of the y-axis, those are greater than the line. Okay? Now when I go back over here to my equation, you're going to see that this says y is less than. So I want the less than section of the graph. So I'm going to shade down here, okay? Because that's where the y-axis is less than the line. So that means at any point in this shaded in section over here, we'll solve that inequality, okay? That's showing us that this is the region where all the solutions are for that inequality, all right? That's what we have to do. Okay, well, let's look at the next example. That's easy enough, right? We just graph it like it's a line, and then we decide which section we need to shade in. All right, the green section or the blue section. Since it said less than, I'm shading on the blue section. All right? Now, let's look at the next example. Oh, okay. Now, you'll remember that whenever we have a line that says y equals something, right, whatever, that is a horizontal line at this number. Okay? Now, you know what? There's something that I forgot to talk about. I want to go back to example 1. Okay? the one thing that I forgot to talk about is this sign, okay, this one right here. It says it's less than or equal to. That means that it can be the line, right? It doesn't have to just be less than the line, that it can also be equal to the line. So just like I would color in a dot, right, if it could be equal to the point, I have to make this line solid because it can also equal the line. Now the reason I came back to talk about this is because when we look at the next one, you'll see that here it says that y has to be greater than 2. It can't be equal to 2. All right? So this is a horizontal line through the y-axis at 2. All right? It crosses the y-axis at 2, but it cannot be equal to this line. So you'll notice I'm drawing a dotted line for my boundary because it cannot be equal to 2. It just has to be greater than 2. Now, again, think about this. It cuts this y-axis into two parts, the green part and the blue part. The blue part is less than the line. The green part is greater than the line. And it says y is greater than 2. So I'm going to be shading up here. All right? Let's see if I can do that pretty neat. There we go. That's better. Okay? This is a collection of all the points that have a y that is greater than 2. Can it be on the line? No. None of the points on the line have a y that are greater than 2. They have y's that are equal to 2. Okay? That's why I had to draw that line dotted. I think you're getting it. I don't need to keep pounding that in there. Okay? Here's another one that we have to remember. Okay? X equals ... is a vertical line. Okay, we remember this. Okay, and it's going to cross the axis, the x-axis at -3. Okay, now look at this. It says it's less than, not equal to. That means my line has to be a dotted line through -3. Okay, now I'll just put -3 there so you can see what that point is. Now, this one's a little bit different because it doesn't cross the y-axis, right? This line is vertical, so I have to think about where the x's are. They want the points that have an x that is less than -3. So that would be all of these points over here. All of these points over here, when I pick this point, its x is less than -3. In fact, its x is -6. Its y is 3. Okay? So all of the points in this section have an x that's less than -3. So all of these points solve that inequality. Okay? All right. Nice. Now I've got one more for you. Okay? This one right here. No big deal. Just like exercise number 1, I just wanted us to practice again. Okay? Let me move my graph up a bit. Now, let's see. Remember, whenever I'm graphing my boundary line, right, I want to make sure that it's in the form y equals mx plus b. And this one is not, because this is behind the constant, and it's supposed to be in front of the constant. So I want to rewrite this as y is greater than -3x plus 1. I just switched the two. Okay? Now it's in the right form. But you know, whenever I'm graphing, I like that to be a fraction, because a fraction helps with the slope, right? The numerator's the rise, the denominator's the run. Okay? Now, I think everything is in y equals mx plus b form now, so I don't have to change anything. Let's notice that this inequality does not have an equal to. That means that my line is going to be a dotted line. Okay? All right. Well, let's see. First thing I do is go to the y-intercept and put a dot on +1. Then I'm going to use the slope to find other points on this line. Down 3 over 1, down 3 over 1, down 3 over 1. Back 1, up 3, back 1, up 3, back 1, up 3. Okay? So there's my line. And remember, I'm going to make it a dotted line. I wish I could draw a little bit better than I am. I can't see. That I was in my I was standing in the way of the light. Okay? So there's my dotted line. You know, I wish I can do better than that. Bear with me. I can do better than that. Okay? Is that better? Okay, maybe. Not really. A little bit. Okay. Anyway, there's my dotted line. Now, remember, it cuts the y-axis into two parts. It cuts it into this part, which is the smaller part, right, the less than part, and it cuts it into this part, which is the greater than part. Okay? Now, with this graph, it says y is greater than the line. So I want to shade on the side that has the greater part of the y-axis, and that's the green side. So I'm going to shade over here. All right? Nice. That means that any of the points that show up in that green shaded region, all of those points solve that inequality. If we plug it in, we get a true statement. Let's just do that. Here's a point right here. That point is 3, 1, right? Now, if I plug that into the inequality, I'll plug it into the original, right? Y, that means 1 is greater than 1 minus 3 times 3. 1 is greater than 1 minus 9. 1 is greater than negative 8, and that's true. All of these points over here, if I plug in their x and y to the original inequality, I'm going to get a true statement. What if I pick one from over here? Mr. C, that's not in the solution set. That would not give us a true statement. Okay, well, let's find out. That's negative 4, comma 1. All right? Let's plug it in and see if we get a true statement. Y is, I'm sorry, negative 1. There we go. Negative 1 is greater than 1 minus 3 times negative 4. Negative 1 is greater than 1 plus 12. Negative 1 is greater than 13. That's not true. And of course it's not true. This point's not inside the solution set. This is where the solutions are. Okay? Or that section is where the solutions are. Okay. You've got it. Good. I don't want to waste any more of your time. Get to it.